name's Tyler Moneith. I'm with NREG's Watershed Assessment and Management section. I'm going to talk today about a project that I've been working on for 6 years now, known as Delaware's Cropland Transect Survey. So kind of what it is we're going out in Delaware, one of Delaware's luxurious minivans, and collecting agricultural best management practice information for the state, largely to go back to Chesapeake Bay for annual best management practice project submissions. So why are we doing this? It kind of started back in 2013. We had one of our progress updates with Chesapeake Bay program, kind of going over where we are as a state in implementing our watershed implementation plan. And one of the things they suggested to us was to look back at some specific practices that we're relying heavily on for meeting our nutrient reduction goals. And two of those practices were conservation tillage practices and cover crops. So these were two practices that were either unaccounted for, or we felt that the actual implementation of those practices was higher on the ground than what we're reporting back to the Bay program on an annual basis. So I'm going to go into a little bit about what conservation tillage is. It's kind of broken up into two categories. On one end, you have conventional tillage, which you see here, where the farmer will go and they'll till in the previous planting material that was left over from last growing season. And what you end up with here is a lot more barren soil that's not quite as protected as if the material was left on like you would see here. And the issue with that is then that the soil is a lot more susceptible to the elements. So like in a large rainfall event, that soil will be impacted by the rain and then potentially carried off field into our waterways. And that's not good for anyone because the farmer wants to keep those nutrients on their field for the crop to uptake them, those compounds. And we also don't want to see those nutrients running into our waterways as well. So kind of on the other end of the spectrum is this conservation tillage idea, where the plant material from the previous planting years is left on the field and it's much better protected. That material will then intercept that rainfall and prevent it from being carried off the field. So previously, the way that we were getting this data for the state of Delaware was from an old survey that was done by the Conservation Technical Information Center, or CTIC. And when they dissolved in 2004, this survey stopped being completed. So we were still using a data set that was definitely outdated from 2004. So we wanted to look back into this practice because we wanted to see how we could better account for these practices on the ground. Another thing is with conservation tillage, the state of Delaware doesn't cost share on this practice, and cost share is a way that we rely heavily on getting best management practice data back to the state so that we can report it to the Chesapeake Bay program. Another practice that we were looking for was cover crops. Cover crops are cost shared on for the state of Delaware, so we do have a pretty good data set with that we provide cost share money to the conservation districts, and they then report back those practice implementation data to the state that we can report back to the Bay program. But the one issue is that, not an issue I guess, but farmers are still out there implementing cover crops and not always using cost share dollars because it's to their benefit as well. So we wanted to see if when we're out here doing this driving survey, if we could collect those additional acres of cover crops to report back to the Bay program. So how are we doing this? Like I mentioned with that CTIC survey that was done, finished back in 2004. So we looked into their survey parameters to see how we could bring this back to the state of Delaware and start conducting this ourselves, and how we could potentially get more benefits from it by implementing cover crop observations to collect another set of data practices so that we could report back. So how do we do this? We collect the data via windshield observations. So we're going out after the majority of the main crops are planted on the ag lands, but before there's canopy closures, that we can make these observations from the vehicle without having to stop and get out and check for residue levels or cover crop plantings every time we stop. We would drive a 110-mile route in each one of our 3 counties, and it would have to go through predominantly cropland land use. In the vehicle, we'd have a driver, a navigator, a data recorder, and lead observers. And we'd also have a QA/QC team going out after the main portion of the survey to make sure that the observations being made were correct and accurate. In order for this to be statistically valid so that we could report it back to the Chesapeake Bay program, we need to make approximately 460 observations in each one of our counties. So the way that works is that we're driving along our survey route and we stopped at specified intervals at either 2/10 or a half mile, and we would observe both sides of the road. So we'd stop, the observers would look out the right. If they saw cropland, that would count as one observation. If they look out the left side and see cropland again, that's two observations. But we don't always see that. So if we stop and they see cropland on the right, but on the left is development, we'd make note of that land use. So we're also tracking the land use every time we're going out to see how the land use could change throughout Delaware over the progress of the survey. And we also provided annual trainings for participants at the start of each survey year, just to make sure that everyone's calibrated and making proper observations. So when are we going out? Initially, when we started doing this, we were thinking we were going to go out one time a year, but that grew as we decided that we wanted to incorporate other observations like cover crop observations. So we start in the fall as the beginning of the cropping season, and we go out in early December, but obviously that varies based on the weather patterns and the planting season. And this is when we collect our cover crop data. So the observers are noting the cover crop type, whether or not it's been planted, how it's planted, and a general estimate of when that was planted. We go back out again in the spring, usually early June, again depending on growing conditions and weather conditions. And this is where we collect our main bulk of the data. We're collecting the residue level in the fields, the main crop type, how it was planted, and like I said earlier, also collecting land use data at that time. We go out one more time. We just finished this. It has mid-June, but we actually went out in July, again, depending on the weather. And this is where we collect our double cropping observations. So this is where if, when we went back out in the spring and the cover crop was still standing, we would go back out again to see how it was either harvested or if it was destroyed, and then what that second planting was for that cropping system. And this is important for reporting this cover crop data back to the Chesapeake Bay program, because they're very interested in whether or not it was commodity, if it was harvested, or if it was traditional cover crop and destroyed. So this is how we thought we were initially going to be collecting all of this. With pen and paper, we'd make note of the crop type observed, the residue level observed, and then go back to the office and input this data in the spreadsheets or whatnot. And obviously this isn't ideal. But luckily I work with some great people that are very focused on using the newest technologies. And it was brought to our attention that we could utilize a ArcGIS software called ArcCollector, which is kind of a mobile ArcGIS app. So we're able to actually upload this onto an iPad and bring it out into the field with us to make these observations. So how it works is, you can see here, we're able to upload the survey routes that we'd be driving, as well as the points that we'd be making our observations at, which are these little orange dots. So when we're out in the field, we're driving along our blue survey route, and we're stopping at these orange dots, and the data recorder can then pull that up, and all the fields that we need to populate are already there. And they can select from the drop-down menu all the options for the data collection at those points. After they make those observations, it gets uploaded onto an ArcGIS server, so it's automatically backed up. We don't have to worry about losing paper. We don't have to worry about something crashing. We can tell whether or not it was successfully saved. So that takes a lot of worry out of it. And then that gets uploaded into the ArcGIS server, and then when we're done the survey, we can go back to the office and get up with our IT department, and they download the shapefile for me, and I can pull it and then do the data analysis, and then give that back to our reporting team that reports that back to the Chesapeake Bay program or any other interested parties that are interested in what we found that year. So some quick statistics. This is from the first year that we did it. And we were in the van for over 72 hours, over 6 days for all 4 of the teams. So we were going a little stir crazy. We drove 1,000 miles just of strictly transect survey that one time. So we joked that while we're driving circles around our little state of Delaware, we could have been Miami. And we made a total of almost 2,000 vehicle stops and may have worn the brakes out of the van. But I will say efficiency has definitely improved over the 6 years. We're now down to a point where each time we go out to each county takes about 1 day or less, especially when we do our Q to QC, when we're just checking about 10% of the observations made. So this is how we generally feel when we're done. This is one of our lead observers, Ben Coverdale. And you can see we're cramped in there with our navigators, our observers, the driver, the observers, the data recorder. and we see some weird stuff. This was in Kent County, where we saw these 7-foot-tall headless mannequins in someone's front yard. This person may have had a little bit too much fun the night before and left their car in a ditch. And then this woman wanted to drag race us on her moped, and she was using her face as a windscreen, so we weren't sure what's going on. So while they're long days, we're usually in there about 10 hours in the van, but we make fun of it, and we have a good group of people that keep things interesting, including her. So this is a little summary of the most recent year, 2017, of data. We just finished 2018, but that was a couple weeks ago and haven't had a chance to run that yet. But as you can see, most of our observations are in this no-till high residue category, where greater than 60% of the ground is covered by residue. And this practice has the best benefit for water quality. When it's over the 60% level, it's been found by the Chesapeake Bay program to reduce sediment loss by 64%. And as I was saying about just benefits to the state, this is a practice that we didn't have a data set on. They weren't collecting at this level in that 2004 set of data. So this is a practice that was out there on the ground over 50% of the time, but the state wasn't getting credit for it in our Chesapeake Bay progress submissions for data. This is broken up by county, again in 2017. You can see Newcastle and Kent tend to have the highest observations in that greater than 60% residue cover. Sussex County tends to be around that 40% level. I think we found a lot of it has to do with what's being grown. Sussex County tends to have a lot more vegetable growers, and vegetable growing tends to be more associated with those conventional tillage practices. And for cover crops, we're seeing about just under 50% for the state average, which we thought was great as well. And then that data then gets reported back to the Bay program as well for additional nutrient reduction credits. So current applications and future work with this project. Again, like I mentioned, we're reporting this back to the Chesapeake Bay program on an annual basis to make sure that we're reaching towards our nutrient reduction and our WIP goals. USGS and University of Delaware have also contacted us for some of this data. They're going out to kind of ground check our observations being made with their remote sensing data to see whether or not their remote sensing data is accurate to the on-ground observations, and maybe potentially using that remote sensing data to replace observations like our technique. And USGS is now analyzing the 5-year data set that we have for this survey. They're going to quantify it and see how observations, how much they change from year to year, whether or not we need to be going out on an annual basis and doing this, if maybe we could do it biannually. And they're also going to be linking these best management practice data to water quality. So they're going to check where we tend to see the highest concentration of these best management practices and relate that back to their water quality sensing monitoring stations to see if we're seeing real water quality improvements with higher concentrations of these best management practices. So conclusion, what does this all mean? To me, I think the biggest takeaway is that we really went out there and saw that farmers are implementing these practices, and it may not be just for water quality benefit, but there's a benefit to them as well, with an economic benefit of not having to go out and till on a regular basis as much, which decreases their inputs, but also keeps the nutrients on their field for that can be uptaken by the crops on their field instead of the nutrients running off, so they have to apply less. So I think it was really important to us as a state to see that these practices are out there and they're having an effect on water quality, improving water quality, and we need to take advantage of that and make sure that we're getting credit for the work that's actually being done out there on an annual basis.
Shore Rivers is an organization that works, our watershed area is basically, we say, from the canal to Cambridge. So that's Cecil County to Dorchester County, Maryland. But also we work in Newcastle and Kent County. I'm fortunate that in our agricultural department, we work throughout Delmarva. So what I'm going to be talking about today is how do we achieve these two important goals of clean water and productive fields. And I think this photo right here really demonstrates what is Delmarva. So this is one of our research sites with University of Maryland looking at cover crop practices. And at shore rivers, we look at really two mechanisms, trying to reduce nutrients at the source, but also trying to treat nutrients through transport. So on the far left is our cover crop research program with the University of Maryland, trying to optimize cover cropping methods in order to reduce nutrients, but also increase productivity. On the far right, we do large restoration projects. We do numerous stream restoration projects throughout the watershed. But in the middle is what I'll be discussing today, is looking at conservation drainage. And we really feel that using drainage to achieve production and water quality benefits is where we can really move the meter on Delmarva. So a quick background. I know everyone is might have a farm background, you might not. You might sit in the office all day. So what is drainage? What are the different forms of drainage? So on the eastern shore, we have a lot of tile drainage. Subsurface tile is able to draw down the shallow water table so that it increases crop production and trafficability. And there's one form that we call is pattern tiling. The idea of pattern tiling is you have hopefully one outlet and you have a lot of small tiles that come off of it. And that's just perforated pipe. On the Delmarva, we do it a little bit differently. This is what you typically see in the Midwest is a pattern like this. Here, to save money, we'll just put in a bunch of tile lines into a ditch. And you can see there's 2 outlets here, and this field has a total of 8 outlets in it. So that's how we kind of do patterning here on the eastern shore. In addition to this, we have random tile. This is much more common in the midshore area. And this is a single tile line that goes to a surface well or tile riser. As you can imagine, this concentrates not only subsurface water, but also moves a lot of surface water quickly from that small depression in the field right to that outlet pipe. So those are the 2 kind of forms of drainage we have for tiling on the eastern shore. And these are some pictures of the old version, which is, we call these tile wells. It just looks like a sewer inlet within a farm field. And this is what people are moving to now, what we call risers. And this is what really old ones used to look like. This was put in, I think it was, he wrote his name on it. He's very proud of himself. It's really nicely done. It was like 1941 or something that was installed and still functioning. So why is agricultural drainage important? Well, first and foremost, it increases yields. Water stress is one of the largest things that hurt crop production. Not only does it increase yields, but it has better trafficability. We have a lot of no-till farms here, but this past year is so wet that the vehicles going across it compacted the soils, so they got stuck. And when you do that, you create ruts, you create compaction. So even though we have a lot of no-till fields, this past year, a lot of farmers went out and did tillage because of the issues with trafficability. So better drainage means you get out in your field sooner, you have less issues with soil health. In addition to this, because we're able to infiltrate more water, we have less runoff. With less runoff, you have lower peak flows, so you reduce flooding. And something that farmers always like to remind me is we put in all these tiles and ditches to also reduce pests. So if you have better drainage, you have less ponded water, you have less mosquitoes, you have less disease moving around. But with the drainage, you're also having impacts. You change hydrology. Generally, you went from a wetland environment to a farm field. And when you change hydrology, especially when you pipe something, you're concentrating dissolved nutrients, the phosphorus, the nitrogen, from the field right into a pipe, right into our ditch or stream. You're going to reduce the effectiveness of some manure management practices, especially if you're injecting manure. If you can imagine, if you're injecting manure into the soil and you have a tile line, you're putting the manure right next to that pipe, which is not a good idea. And finally, we're circumventing ecosystem services. So these pipes generally go under our riparian buffers, so it's not even going through that buffer at all for any kind of treatment. So those are the issues and also the benefits of drainage. And then sediment. So we have those open tile risers and tile wells. And you can see background base flow. You have a storm event. It's moving that sediment from the farm field to that pipe, to the outlet, right into that stream very quickly. And in this event, we collected a sample that was 8,000 milligrams per liter of just pure sediment. And obviously, if you're moving sediment, you're also moving phosphorus. So this is showing a graph of sediment going through that tile line, and then you can also see peaks in total and dissolved phosphorus. And then finally, because we're focused on the Nanticoke, this data is from a tile in Dorchester County that goes into eventually the marshy hope. So during base flow, nitrate is moving, it's high in groundwater, and this has tile wells at this site. And as soon as it rains, you can see it flip-flop, and the phosphorus rockets up because it's attached to sediments, it's moving with that storm water, and the nitrogen goes down dramatically. So that's the issue that we're trying to resolve here by putting new restoration projects on these tiles. So this is my conservation drainage umbrella. This took me a while to make this graphic. I'm very proud of it. So what falls under this umbrella of conservation drainage? At the core of it is just purely drainage water management. It's such a simple idea, and it's something that I'm telling everyone, if you're putting a tile line on, just do this. So at the core of drainage water management is just putting on what we call a structure for water control. And the idea of this is that we only want to drain the amount of water we need for production. If it's the middle of December, you don't need your tile line running. You have the thing you might have cover crops out there, they're going to be okay, they'll make it. So the idea is only drain the water when you need it to get out in the field and to grow a crop. And then manage that water through the growing season. Water is a resource. You need to manage it. You can increase productivity by doing drainage water management by 3 to 5% because you're able to keep more water underneath your field. You can reduce nitrate by greater than 30% because you reduce the drainage. Your crops are taking up more nitrogen, and that was recently, I guess at NC State, they showed data on crop tissue nitrate values under drainage water management. It was higher, so they documented it in that study. In addition to that, we're forcing water to find different ways to get to the stream. Rather than going straight to the pipe, it's going through more natural subsurface routes to get to that ditch or stream. So we have a chance that nitrogen is going to interact with zones of denitrification as it gets there. Finally, for drainage water management, we need flat topography. So the lower eastern shore, the Nanticoke is a great place to do that kind of stuff. NRCS has plans. We have different kind of standards to do all this. And I'm working currently with Ecosystem Service Exchange throughout the state of Delaware to help implement more of these projects. And we estimate that in Sussex County alone, we have 191,000 acres that we can do drainage water management on. In Kent County, we have 133,000 acres. So there's a lot of opportunity in Delaware to implement just drainage water management. And this is a project site down in Somerset we completed this past winter. So now that we're managing water, what's the next step? Well, let's treat the nitrate at the outlet. So the next one is a saturated buffer. And the idea of the saturated buffer is we're using that same structure for water control, but now instead of just managing the water, we're pushing it back out underneath that buffer that's against that ditch or stream. Very simple passive project. It's very cheap. The additional cost there is that one distribution pipe that goes under the buffer. This is what it looks like. This is the first saturated buffer in the mid-Atlantic. This was installed in Caroline County this past fall. So here's that structure that manages the water in that tile. And here you can see we divert it into that riparian area. We can get approximately 50% load reduction because these systems are also there for maintaining drainage. So there's going to be bypass flow during big storm events, so we're not getting 100% treatment. And when it's done, this is the tile line originally came right out here. We put in that box, and we have 2 distribution pipes that go underground in that buffer area. Very cheap, very simple. It's using the ecosystem benefits we have there already through things like CREP and CRP to our advantage. So the next one is where I got my start was denitrifying or wood chip bioreactors. Say we don't have this nice riparian buffer that we could divert water into. What can we do in order to reduce the nitrate in a small area? And the idea of a bioreactor is that we're diverting water now into a wood chip trench. The wood chip trench is just like a wetland environment. It has the carbon you need for the host the bacteria. Eventually, the bacteria take out all the oxygen, so then they move to nitrate as their next oxygen source. They get rid of the nitrate. At the very end of this is piped back into the original pipe or right into the ditch at a lower concentration. Fairly small, 30 feet by 100, so you're not taking land out of production, and you're still achieving that water quality goal, as well as still maintaining the drainage that we need for production. Similar to a saturated buffer, 30 to 50% load reduction, and it works in either a pattern or random tile system. And this picture was taken by Dave Harp. This is the second bioreactor ever installed in Maryland. This is up in Queen Anne's County. And then finally, we were talking about those well or tile risers. How can we get rid of those? How can we have a system that maintains the drainage in the field but reduces that sediment and phosphorus transport? And this is what we call blind inlets. So here's a tile well or tile riser. So instead of those, we are now transitioning to a filtering practice. And this blind inlet was the first one installed in the Mid-Atlantic. And this is in the Dorchester County site in the Nanticoke. So very Nanticoke specific project. So the idea of, and this might terrify some farmers to see that picture, but the idea of this practice is that instead of just an open riser, we have more or less a French drain. It's going to have coarse gravel in the bottom. It's going to have perforated PVC. And then on the top layer, we can either put in pea gravel, or in this case, we just use sand in that top layer. So the water filters through this. It keeps the sediment within the field. The phosphorus is adsorbed to the sediment, so that stays in the field. And if we're really concerned about reducing phosphorus loss, we can use slag instead of that gravel. It has the same kind of size, so it has the same kind of flow rate through it, so it's not going to affect the system. We're seeing greater than 75% load reduction for sediment and phosphorus. And the nice thing is that, as you can imagine, if you're driving along in your tractor or combine and you hit a tile well, you might break your axle. And this, the farmer actually planted through the side of this one, and the soybeans are coming out of it. So you're not going to impede farm equipment. So that's a great selling point there. And this is what the bones of that look like here. There's practice standards. It's very straightforward practice. And this is a site in Kent County, Delaware, where we're comparing a blind inlet to a newer water quality riser to see how much sediment moves through those systems. And then finally, I didn't have this on the umbrella because it's kind of just outside of conservation drainage. Constructed wetlands. We can do this without a drainage network. We can build these anywhere, but we can also tie them into existing tile lines because we can use it as the water source for the wetland and then manage it using a water control structure to change the levels within that constructed wetland. We completed the first project like this in Caroline County. We just finished this about a month ago. And you can see here we have a random depression that they want to drain. So we took that tile line, put it into the wetland area. We had another tile line coming in, and there's actually a third one coming in here. So we directed all the field's drainage into this acre wetland for treatment. And you'll probably get 60% nitrogen, phosphorus, and sediment reduction just by having that wetland there. So not only did we create drainage that we need, but we also created water quality benefits as well as habitat benefits. So this really checks off all the boxes. So I wanted to make sure that when we're talking about this, we could talk about something happening in the Nanticoke. So I keep referencing the project in Dorchester County, and this is it. It is in the large town of Williamsburg. I'm sure everyone knows exactly where that is in Dorchester County. If not, it's kind of near Hurlock and in between Hurlock and Federalsburg. So this is what the system looked like originally. So this is the feeder ditch. The Marshy Hope is just barely off the screen here. We had a tile put in. I think it was put in piece by piece from 1975. I think they finally finished it in about 2011. So it's just a random lines. They went out, and here's a wet spot, let's put another line in. And then they kept putting in wells wherever they felt like they needed to surface wells. So overall, it was draining about a 20-acre field through this system. And this is what it looks like out in that field. So you can see they have random lines coming into this well, and they would go down to that pipe. So in order to really upgrade the system for conservation drainage, we had to do a total retrofit. So that random tiling with the wells, we replaced with 2 blind inlets in the field. And this has its own pipe that goes to the outlet here. And then we did pattern tiling for drainage water management on the perimeter of this. And this has its pipe that connects into that larger pipe to the one outlet. So we're now just managing this one outlet in that field. So that's what was there. That's what we installed out there for the blind inlet. And at the outlet, as I keep preaching to everyone, if you're putting a tile line in, why don't you manage it? So we put a water control structure on the outlet, which is cost shared through the state of Maryland. So this is the agronomic benefit, putting in that new tile line. And then this structure here is the water control structure being installed just to manage the pattern tile, the drainage water management portion of it. And this is what it looked like a few weeks ago. But he's managing 16.3 acres of that field with that one box. So there's tremendous benefits by just putting that water control structure on there and understanding how to put a system, install a system for that. So what does this look like? Because when you talk to a farmer about all this, they're saying, what's the bottom line? What's my return on investment doing this? Other than water quality, which I tell them it's a tremendous benefit. So looking just at a random tile, so if you're to go out and say, I need to replace my tile line system, I'm going to put risers in instead of these old wells. I want to do, generally projects are about 2,000 linear feet. You're putting in one riser. And this down here, if you're really interested, you can read all the fine print, and that's kind of your typical drainage practice. But that'll run a farmer or landowner just over $15,000 to do. So going through cost share, though, we're able to reduce the cost to the farmer or landowner. And this is doing a saturated buffer plus I call it a rock inlet here, but it's also rock or blind inlet. It's the same terminology. Reduces the cost to the farmer or landowner. The state or NRCS is cost sharing portions of that. So we have a return on investment on the typical one of 13 years. Going through cost share and trying to do water quality benefit, the return on investment now is only 8 years. So these are the discussions that we're having with landowners saying, you need the drainage. We want the water quality and conservation goals. Let's pair them together. The incentives exist, and it drops down that cost to that farmer or landowner. When we look at pattern drainage tile, the return on investment is not as great for that conservation because we're not adding in as many conservation practices. We're generally just adding in that water control structure, and you cannot cost share that 4-inch tile line because that's just purely agronomic benefit there. But we are reducing the return on investment from 14 to 12 years. And obviously, if you added more expensive conservation practices to that, your return on investment is not as great. So if you do it with a bioreactor, it's around 13 years compared to the traditional 14 years. So going through all this, we did the cost share route, and we had about a year to do all these projects and practices. And we found that when we cost shared it, we had more people try to go through our cost share program than we could fund. So in the end, we were able to install 8 blind and rock inlets, 4 saturated buffers. We had 2 projects that used drainage water management, but we also created 5 plans because then we said to the farmer, well, you have 3 other fields out here. Why don't we just get them set up for drainage water management? So when you have the funding, you're ready to go. We have 2 projects that use phosphorus absorbing materials. We had 1 created wetlands. We have 8 fields with improved drainage, and we have greater than 100 acres treated. And to give a perspective, the state of Maryland within its WIP 3 is looking at about 18,000 acres of drainage management. So the incentives are there. We can make crop production work. We can get our water quality benefits. So we're really excited to see where this goes in the future. And with that, I'm done. Am I on time?